That's a quadratic, yes. That's on the front page, front part of your page. It's a quadratic, which is degree what? 2. It's quadratic for x squared, right? Degree is the largest exponent, right? That's what you're going to sketch on the front part of the page. And on the back side of the page, you're going to do f of x equals x cubed minus 4x squared plus 3x plus 1. So you're going to sketch these accurately, and then I'm going to come around and judge you. I'm going to judge you. Full judgment. All the judging. So there has to be arrows. There has to be coordinates. You can't look like you just sketched it off your screen willy-nilly. It also can't look like you were trying to do it on your bus while going over 720-foot speed bumps. Yeah. Okay. So we're going to sketch them, and then I want you to give me the x-intercepts. Y-intercept. The max mins. What else do you think I want? X-intercept, Y-intercept, max min, what? Domain and range.
You have to do that too. See if I care.
We are going to put this one into our calculator, which is x squared minus 4x minus 5. And remember, we can go zoom 6 if we have a crazy window, right? It'll set us back. So what's the very first thing I would get? I would get the minimum. Most people get the minimum. So we do second, trace, minimum, which is 3. Now, does a regular 10, 10, negative 10, 10 window work for this graph? Yes. But if it was outside of that, you might have to make each tick worth 2, right? So you'd say x scale of 2 and y scale of 2, or whatever you wanted to do. The x scale and y scale can be different. But we do second, trace, minimum, which is number 3, left bound. Come on, join me, move up. Left bound, enter, right bound, enter, enter, and I get 2 and negative 9, right? So, you have to do this. X scale, I'm making them each worth 1, correct? And then my y scale of 1. Now that graph that we were looking at on your assignment, you need an x scale of 1, but a y scale of 2, because the minimum went to 14, right? Negative 14. But the graph only has 10 ticks. So you have to make your y scale be 2, so that every 2 ticks you can fit that negative 14 on there. Does that make sense? So you would go to the 7th tick, which would be worth negative 14. So you have to say what your scales are. Even if they're 1, you have to say what they are. Now your x scale could be 1 and your y scale could be 2. They don't have to be the same. So when you draw them out, that's what you need to do. So my minimum was at 2 and negative 9. So I go to 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 and negative 9 is down here, correct? Then I need more things, more points, yes? So I know 2 and negative 9, and then I can go second trace value, and I can work my way out. So I put in a 3, enter. Oh, I get 3 and negative 8. Okay? And I go 4, enter. I get 4 and negative 5. So I say the only reason why graphs are crappy is laziness. That's it. Because your calculator does the work for you, right? Now, could I even put more coordinates in between there? Yeah. I could go 3.5 now, enter. Not 30, that would be down. 3.5, enter. Oh, 3.5 and 6 point, negative 6.75. 3.5 and 1, 2, 3, 4, 5, 6.75. Oh, that's like down here. There's no reason to not have more coordinates other than you don't want to draw more coordinates. Correct? Which isn't a good enough reason. Then I go 5, enter. 5 and 0. And now most of you would willy-nilly the arms. Do we do that from now on? No, no, Katie, no. 6, enter. 6 and 7. Now, if we look at this coordinate that I have up here, from here to the edge, I'm going to go draw, draw, draw. If I felt like there wasn't enough in there, I can put another coordinate in there. Draw, and then I put a little extension and an arrow, right? Because this graph keeps going. Yes? Does that seem like a more accurate graph in front of your face? That would get full marks. Does that seem more reasonable as to how to find it? How to get the coordinates for it? I could have gotten more coordinates in between because I could have done 4.5 and 5.5 and get more coordinates, couldn't I? All it is by going 4.5 enter. Like it's not aggressively hard to get more coordinates. Yes? Do you agree? Okay, that was at 2. So then I can go 1, enter, and I get -8. Then I can go 0, enter, and I get -5, which I knew already existed because of this, right? Then here, then here. And if I want more, I can do like -1.5. And 3.25. And then I get another coordinate in there, right? There's no reason to have lack of coordinates because your calculator does it for you, right? It's not like it's extra math. That was bad. Now guys, I have to tell you, this should be rounded, correct? This should be rounded down here. It should not be a point. A point is an absolute value graph. It should be a bit rounded. Okay, every quadratic should be, yeah.
What if you have a little silly calculator that doesn't do the work for you?
It will. Yeah, press the button. It'll still do it. Go second. Put in your equation. And you just do second trace value. Yours is exactly what mine does.
No, because every time I do second trace value, it just goes to what I last had. Like if I was.
Yeah, you guys put in any value. Do it. Trust me, it works. I'll show you. We're just making a little oopsie somewhere then if it's not working. So what were my x-intercepts at? Let's check and see if you did it right. -1, 0 in brackets. Some people are listing coordinates without brackets. Some people are not listing coordinates. And 5, 0. That is if I ask you for x-intercepts. We agree? If I ask you for the number of x-intercepts, what would you tell me? Number of x-intercepts. How many would there be? 2. Very different question, correct? Number of x-intercepts is how many there are. The x-intercepts are what they are. The y-intercept is at 0, -5. I don't even need my calculator for it because the constant is my y-intercept, correct? My maximum doesn't exist. My minimum is at 2 and -9. My domain is x such that x is an element of the reals. There's a few of you that I didn't dock anything, but do you see how this is a y? I can go y such that y is greater than or equal to, what's my lowest y? It's a 9, correct? 9. Y is an element of the reals. Did you get to work, Andrew?
Yeah.
Okay.
I'm just.
If you were just pressing, like, just it'll get you trace and then it.
Yeah. I was just thinking.
Oh, yeah. Yes, do second trace. Negative second call. Thank you. Right? Okay, you guys drew the cubic, but I want to keep going on to more stuff, okay? Just so we can get through more of the things. So I want a reminder. What was the very first equation we looked at? What type? Even before that, we looked at constant, right? Which you guys fell for. That was like y equals 6, right? It just gave you a horizontal line at y equals 6, let's say. That was the very first polynomial we looked at, yes? Polynomials, remember, have x values or constants that are whole numbers. So x, this one would be like 6, but I could put behind it x to the 0 technically, right? Because to the power of 0 is just 1. So as long as it's just a number or an x to the 1, x2, x3, x4, it's a polynomial, correct? This one's a constant function. Its domain would be x such that x is an element of the reals. But what's its y? What's the only y's on this graph? Y equals 6. Right? It's the only thing that's on this one. There are no other y's. Everyone is 6. So everyone forgets that that's a polynomial. Right? The other one we did was linear. Linear is in the form y equals ax plus b. Now, guys, what I find is when I ask for an equation, you guys forget to write y equals. You'll just give me like y equal, you'll give me 7x plus 6. That's not an equation. Y equals 7x plus 6 is an equation. So if I ask for an equation, you'll see in your assignments a lot of you did not go y equals. So you're going to get docked because that's not an actual equation, right? So y equals this. So what can you tell me about linear? This back number is what? The b gives me the what? This is going to be my constant, which is also my y-intercept, yes. Because when I plug in x equals 0, the rest goes away. And what does your leading coefficient tell you?
Direction.
Direction on what?
The arrow.
Which arrow?
The right.
The right arrow, yeah. No, come on. I hate this thing sometimes. I didn't want to review today anyways, so thanks. Not very smart. Okay, so this was my constant, or my y-intercept. This is my leading coefficient. And it tells you how it ends on the what? On the right. What degree is it? What degree, guys? Degree 1, because it has a exponent of 1. It discos, right? If it discos and it's not a word problem, what is my domain and range? Yeah. So this one's going to be x such that x and L in the reals. Every polynomial is that. And my range is y such that y is an element of the reals. Every linear is. Also, every cubic is. Every odd degree is. Yeah.
So if A was negative, it would be down on the left.
So it was on the right. So it'd be down on the right and then what on the left? Up as this goes. So your leading coefficient tells you how it ends on the right. Okay? So if I gave you a graph like this, what could you tell me about the leading coefficient? The leading coefficient is what? Positive. Because of that, right? Every graph we can tell if it's positive by the right. So if it's up on the right, it's positive, whether it's quadratic, cubic, linear. Okay? It's just a catch that with linear and cubic, it just goes. So it's in the opposite direction on the left. With quadratic, it's in the same direction. Okay, what can you tell me about the y-intercept? x equals 0. And what would my y-intercept be here? Positive or negative? What's my y-intercept? It's positive. So it'd be 0 and some sort of positive y value, right? So what can you tell me about the constant of the function? The constant is positive. Remember, the constant is the y-intercept. The constant is the number without a variable. We agree? Okay, how many x-intercepts can a linear have? 1. What's the minimum and the maximum number? So remember, number of x-intercepts, the maximum is equal to the degree, correct? So the maximum number of x-intercepts a linear can have is 1. When it is odd, it discos. So at minimum, it can have 1, right? If it discos, it's going to have at minimum 1. Yes? So linears and cubics have at minimum 1. So at max, it has 1 for this one, and at min, it has 1. So it's always going to have 1. Correct? Do you agree? So that's linears. And we're going to do the other odd function right away, cubic. Okay? So if we have y equals ax cubed plus bx squared plus cx plus d, this is cubic, which is degree what? Degree 3. This is my constant, which is my what? Y-intercept. You see how it didn't change, even though it didn't change in the pen change. Okay. So that's my y-intercept, and my leading coefficient tells me how it does what? Ends on right. It doesn't change. Did it matter? I said it doesn't change, and the pen changed again. Yeah. Whoa, I put right with 2 T's. All right. So, what are the number of x-intercepts a cubic can have? The max is 3, so that's one possibility. What's my minimum? 1, because it's odd, it discos. It's going to have to go through at least once. And then I can have anything in between the min and the max. So what number falls between there? 2. So I could have 1, it could look like this. I could have 2, it could look like this. And then I could have 3, it could look like that. We agree? Okay, number of turning points. Turning points are just a fancy way of saying what's? Max and mins. So it can either have 2, a max and a min, or it can have how many? 0, because it can do this. Remember what this is called? Point of inflection. Would I get any marks for these graphs for accuracy? No, they suck. But for what I'm doing, they're good.
Well, it could be accurate in some way.
It could be. I'd have to find out the equation that accurately fit that.
Just give us the word.
Okay, so if my function, excuse that, I'm trying to prove a point. If my function is that, still cubic, correct? What would my constant be? 0, right? Okay, so what would my domain be for this function? X such that X is the name of the reals. It always is that unless it's a word problem, correct? What would my range be? I gave this to people, but you guys are almost 95% of you would have gotten no marks. F of X. You guys said Y such that Y is now in the reals because it discos. True, except Y is not existent on this equation. It's a F of X. So it would be F of X such that F of X is the noun of the reals. We agree? Okay, if I gave you a graph instead of an equation, say I gave you a graph like this, what could you tell me about the leading coefficient? The leading coefficient is positive. Why? Because it is up on the right, correct? What could you tell me about my y-intercept or my constant? Positive or negative? Positive. Please write the word positive on an actual exam. So that's cubic, correct? What's the last one we didn't do? And cubic is degree 3, yep. Quadratic. Quadratic is like y equals ax squared plus bx plus c. And quadratic is degree 2. Okay. So, once again, this is my constant or my y-intercept, correct? And once again, this tells me how it ends on the right. Also how it ends on the left indirectly because they're going to end in the same direction because it's degree 2. Yes? Okay, this one, number of x-intercepts. How many x-intercepts can it have? 2 is the max. Why? Because the maximum is equal to the degree, right? It can have 2. Catch with quadratics because their arrows are in the same direction. What's the minimum it can have? 0. And then we can always have variance in between, right? What number falls in between them? 1. So it can have 0 because it could go like this, right? It could be completely above because the arrow's in the same direction. It doesn't disco. Or it could have 1. Or it could have 2. Right? Now, if this is the function I'm looking at, what's my domain? And I'm going to tell you, this graph is actually the graph of g of x. Ooh. So what's my range? And then g of x is element of the Okay, we're going to give examples of what's not a polynomial. So what is a polynomial? Constants, linears, quadratic, or sorry, constant, linear, quadratic, cubic. But what is not a polynomial? That's calculus. So say I give you this, y equals 3 over x plus 6x squared minus 2. That is not a polynomial. Why? This is x to the 1, but it's in the denominator, correct? If I rewrote it, I could rewrite this as 3x to the negative 1, could I not? By bringing it up, we talked about this. Plus 6x squared minus 2. So this is not a polynomial. Polynomials have to have whole number exponents. Okay? This is also not a polynomial. Y equals 7 to the x plus 6x minus 3. I can't, is that a whole number exponent? No, that's a variable exponent. The other one that it can't be is this, y equals 2 root x plus 6. Root x is the same as x to the half, right? That is still not a polynomial. People will tell me this isn't a polynomial, but it is. This one is a polynomial. Y equals the square root of 3x squared plus 6x minus 4. What are my exponents? 2, 1, x to the 0. Are those all whole numbers? Yeah, it's a polynomial. This is just a decimal in front of my x squared. Doesn't affect the x, right? That is a polynomial. People say it's not. Okay, you fall to that one? Yeah.
Could we go over like what the domain and range of the other problem?
Yes, I did. Yeah. Yeah. That's what we're going to next. Okay, I'm giving you a quadratic. Word problem. Let out of here to see what happens because this book sucks. Oh, I forgot to press record. So this is the height of a football being kicked. H of t is height in feet. T is time in seconds. I want all the questions answered, and then there's 2 more questions that I could ask you. I could give you a specific height and ask you for the time it takes to reach it. I could give you a specific time and ask for the height of the football. Okay? Come on. Now, I just sketched that willy-nilly out of like thin air because it didn't ask me to graph a graph, correct? I always just graph the graph myself and then put the main points, sketch them on there to help me make answers. Okay, so when I do these, I label it, I put a coordinate at like 0, 4, but I don't just go 0, 4. I put 0 seconds for feet. Like I put the unit so that it helps me out, right? It's easier if you write the coordinate with feet. And then my maximum is at 2 seconds, 68 feet. Because then I won't pick the wrong number, hopefully, when it asks how high is the maximum height, you guys go 2. Well, you'd go, how high is the maximum height? 2 seconds. And I hope you go, that makes no sense. And then you say, oh, it's 68 feet. That makes sense. That's why I always unit my coordinates. And then it hits the ground at 4 point something.
4.1.
4.1? Yeah, 4.06. So if I say to the nearest tenth, it would be 4.1 seconds, 0 feet to help ourselves out. Correct? All right. Okay, let's answer some questions. The height of the ball the moment it was released. 4 feet. How many marks you getting? 0. So, I actually gave 0.5 because I was kind. The height of the ball the moment it was released is the y-intercept, which is this. 4 seconds. Didn't even need my calculator, correct? Okay, the maximum height of the ball. The maximum height of the ball is 2 seconds. Oh, it said height, which seconds is not height. Shocking. The maximum height of the ball is what? 68 feet. You see, if you write the units, it's a lot harder to oopsie. The time to reach maximum height. The ball reached maximum height. When I was writing, reached maximum height at 2 seconds. Time the ball hit the ground. The ball hit the ground at 4.1 seconds. Okay, this is where it goes downhill. Yeah.
For number 1, it's 4.
4 seconds. Oh, I would have sucked. See, look at that. I would have wrote 4 seconds. What the heck are you doing, peeps? And then I would have like circled it and like, no, sad face, tears, 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 puddle. Okay. I wouldn't got 100%. Okay, domain and range. This is where it goes downhill. We agree? We talked about this before. So let's discuss this before we do this. So we do time t. We slot our t in the middle because there is a lowest t and a highest t that this graph can do. What is the lowest t? I like quadratics because they give me low and high and it just makes my life so much easier. What's the lowest time I could be? 0 seconds. What's the, when did it hit the ground? 4.1, correct? So t is, if it's open to the t, it's greater. So t is greater than or equal to, what's my lowest one? 0. And if it's close to the t, it's actually less. T is less than or equal to what? 4.1. T is an element of the reals. If you remember low to high and loser, loser, I sometimes remember that, makes L's. Do you see how it's L's? Slanted L, low to high. It works every time. Yep.
Will they always be the same?
If you're going, if they're squished, if they're sandwiched, yes. Yep, low to high. Because you're reading from the t. So t is greater than or equal to 0, t is less than or equal to 4.1. So that's why they're in the same direction. They make L's. But you have to go low to high. If you go high to low, which people try and do on me, then they're the complete wrong direction. Okay? Now my range is h of t. Slot my h of t in the middle. H of t is greater than, H of t is less than, low to high. You see how it's not that crazy? What's my low? My height can be 0 when it hits the ground. What's the height? Highest it can be 68. We agree? Okay, then I told you there's 2 other questions I can ask you. Okay, at what times does it reach a height of 40 feet? And then G, what is the height at 3 seconds? If I give you anything below 4 feet, look, if I give you anything below 4 feet, there's only one time, correct? Anything above 4 feet, it's going to cross the 2 spots. So sometimes they ask for the first time it reaches 40 feet. Sometimes they ask for the second time it reaches 40 feet. Sometimes they ask for the times, which I ask for the times. So I'm expecting 2 answers, correct? So I go to my y2 because this is feet, so this is height. I go to my y2 and I'm going to put in 40. And then I can find the 2 times. So second trace 5. Enter, 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 and I get x equals 0.7 seconds. And by x I mean t. 0.7 seconds. And then .3. And I expect decimal. And I expect a statement, right? The times at which the ball reaches the height of 40 feet are 0.7 seconds and 3.3 seconds, okay? Then at what height is it at 3 seconds? Or you just go second trace value. It's the place where you put an x in, right? Second trace value 3, enter. 52 feet. So we say the height at 3 seconds is 52 feet. I have one more thing that I want to talk to you about. So most people are really good at getting regressions. I've seen it, correct? You guys can get your regressions. That's where you do SAT, calc, edit, put stuff in, linear, quadratic, cubic, 4, 5, 6. Yes? What I have seen though is that people don't know how to write the equation. So if I ask you for the equation, if it was cubic, you'd go y equals, and then you'd put the a, because it goes like this: ax cubed plus bx squared plus cx plus d, right? And then it says A is 3.57698, B is 4.2695, C is 8, D is negative 7.43. Okay? I've gotten the craziest crap. You need to give me the equation. If I say to the nearest 10th, you need to round these each to the nearest 10th and input this in for A, that in for B, that in for C, that in for D, correct? So my equation, if I said to the nearest 10th, it would be y equals 3.6 x cubed plus, this looks 5 higher, so 4.3 x squared plus 8x minus 7.4. Do you see what I mean? So it'll say nearest 10th where necessary most often, so you don't have to. If it's a nearest 10th, yes, you actually go 8.0. Absolutely correct. Do you understand how you write those in? Okay? And then what's on the test as well tomorrow? Rationals. Okay, rationals. So please go through. How do you study rationals? You go to the notes package and you cover up answers and you do the questions in the notes package. You don't need extra questions. You need to just practice what you have. And the notes packages are the best because guess what? They have solutions which are correct. And you know they're correct. And you can love it.